In the silence of space, every object pulls every other object. That unseen connection is gravity, the fundamental force that shapes the universe. It began with an apple. Newton realized that the same force making an apple fall keeps the moon in its perpetual orbit around Earth. He proposed the universal law. Every mass attracts every other mass, proportional to their masses and inversely to the square of their distance. Mathematically, F equals gm1 m2 over r squared. G is the universal constant, a fixed value for all bodies everywhere in the cosmos. Gravity provides the necessary centripetal force that maintains planetary motion, beautifully explaining all of Kepler's laws. The force decreases rapidly with the square of the distance. That's why the gravitational pull on the moon is much weaker than the pull on you.
Near Earth's surface, the acceleration due to gravity is 9.8 meters per second squared. We denote this value as g equals gm over r squared. The value of g changes slightly. It decreases with altitude and also varies with latitude, being highest at the poles. Crucially, g also decreases inside the Earth. As you descend, the effective mass pulling you downward is significantly reduced. When an object is thrown upward, gravity acts downward, decreasing its speed until it stops momentarily, then accelerates it back down to the ground. In a vacuum, all objects fall with the exact same acceleration. The gravitational force is proportional to mass, but so is inertia. This is proven on the Moon, where there is no air resistance. A feather and a hammer fall together, a uniform acceleration for all objects.
Lifting an object requires work against gravity. This work is stored as gravitational potential energy, which is mgh near the surface. In general, gravitational potential energy is defined as negative U equals negative g mm over r, because work is required to break the bond of attraction. To escape Earth's gravitational pull completely, an object must achieve the escape velocity, a minimum speed of approximately 11.2 kilometers per second. If the speed is less than the escape velocity, the object stays bound, achieving a stable orbit, a perpetual freefall. Higher orbits experience a weaker gravitational pull, and thus require a lower orbital velocity to maintain their stable circular path. A crucial geostationary satellite orbits once every 24 hours at about 36,000 kilometers, staying perfectly above the same point on Earth. The total energy of a satellite, the sum of its kinetic and negative potential energy, is constant and negative, ensuring it remains bound to Earth. Gravity explains the tides. The Moon's differential pull gently raises and lowers the water levels, showing celestial forces in our daily lives. From a simple falling apple to the intricate spiral of a galaxy, gravity is the invisible, elegant thread holding the entire cosmos together. Invisible, eternal, and universal. Gravity is the simplest force to feel and yet the hardest to escape. It is the steady heartbeat of the universe itself.